Here it is given that a quadrilateral ABCD is drawn to circumscribe a circle. Circumscribe means around the circle if you are drawing the quadrilateral. Okay. Then we have to prove that AB plus CD, this AB plus CD will be equal to AD plus BC. That means whenever a quadrilateral is circumscribed by a circle, a quadrilateral circumscribes a circle, the sum of opposite sides are equal. Generally for the quadrilateral, the sum of opposite sides are equal. You look at this, AB and CD are opposite sides, right? So sum of opposite sides are equal. That one you need to prove. So instead of approaching this like a side, we can approach it like the tangents drawn from an external point. This is one such easy question, man. But if you get confused means everything will be collapsed. So for that, I'll tell you one thing, just simply follow this. We need to prove this AB plus CD, right? This is already given in the question itself. So you just follow this. Parts of AB and CD alone, you write it here. Okay. So we know that you're going to calculate left hand side, man. So for that, the length of the tangents drawn from an external point to a circle are equal. Okay. So we have, see, look at this carefully. First list out the pieces of AB. Okay. So what I am writing is AP is equals to AS. So whatever you write, you make sure the pieces of this left hand side comes in the left hand side. Okay. And then AP I written. Next what I will go with PB. So pieces of AB I written, right? So PB is equals to QS. So pieces of AB I written. Next guess what? Pieces of CD we should write. It is not that seeing the diagram you are just writing all over this thing and you don't know when to compare, what to compare. No. Simply pieces of AB written and then pieces of CD will write. So CR is equals to what? CQ, equation 3, and then CR done, and then DR or RD is equals to DS, equation 4. Now add everything, man. 1 plus 2 plus 3 plus 4. See, again I am saying you should not write as like your wish. Simply follow this one. Left hand side, A, B, C, D pieces alone should be in the left hand side. That like you should follow. Remember in congruency we should follow this. Pieces of this parts of this triangle will be listed left hand side. Parts of this triangle will be listed in the right hand side, right? So that like. Now add everything. Yes, sir. PB is equals to, oh sorry, I wrote QS. Sorry man, sorry. PB is equal to QB. Good. And then left hand side I added. Plus here also left hand side we can add. CR plus RD is equals to, right hand side as it is we can write, no problem. AS plus QB plus CQ plus DS. Okay. Now as usual AP plus PB, that like only we taken right cases of AB. When you add these two, what you will get is AB plus this one, when you add what you will get is CD. Okay. And that is equal to, here you just look for a common alphabet, man. That's enough. Is there any common alphabet is there? AS, DS is there. When you join those two AS and DS, what you will get? See, the common alphabet S is there, right? That's why I am combining them. So AS plus DS is what? AD. Plus here also look for the common alphabet Q. BQ and CQ. BQ, CQ, no, that is EC. That's all. Easy, right? But If you are not revising properly, simply as like you wish if you written means. Suppose you are writing that AP is equals to AS, and after that you are following this line the anti-clockwise. DS is equals to DR, and then RC is equals to CQ, and then QB is equals to TB. Now we have to combine everything, we should get one. If you add everything, left hand side, right hand side, we can add it. Is it possible to group them, you see? No, we don't. So, this will be clumsy. Though it is right, it is not helping us to prove the result. So, simply do this in this order. That's what I mean. Got it? And then, as an extension to this question, that the question number 11, you see, prove that a parallelogram circumscribing a circle is a rhombus. Same kind of question. The question number 11, it states that the parallelogram circumscribe circle is a rhombus. So, circle is there. We are talking about a parallelogram. Same like we'll take. Same diagram, man. But what I am doing here, like parallelogram I am drawing here. Okay. Same like we can prove this. We'll be arriving at the result AB plus. I am taking it like we know that from the result. But in exam we have to prove, man. Okay. You can't take this like the result. So we know that like I am taking here. But in exam this is the first half of this question, man. Okay. So this is AB plus CD is equals to AD plus BC. Now, what makes a parallelogram rhombus, you know? What is the difference between parallelogram and rhombus? In a parallelogram, opposite sides are equal. Remember? Whereas in the rhombus, all the sides are equal. Okay. So it is enough to prove that here already opposite sides are equal. If we can able to prove one pair of adjacent sides is equal, now everything will be equal, is it? That's what we need to prove. How to prove these adjacent sides are equal, man? We'll make use of this. So, in a parallelogram, and also that in a parallelogram, opposite sides equal. That means we have AB is equals to CD and AD is equal to BC. Substitute that in 1. Then we will be getting 2 times AB plus, not plus, equal to. So instead of CD I substituted AB. Now which is the adjacent side for AB, man? So either we should get AD or we should get BC. Whatever it is. So in terms of anything we can want. 2 times BC I am writing. 2 gets cancelled. We get AB is equal to BC. Alright. But AB is already equal to what? CD. Also this BC is already equal to AD. That means all the sides are equal. In a parallelogram all the sides are equal. Then how do we call it? All sides are equal in the parallelogram ABCD. So that means this parallelogram ABCD is a rhombus. Okay, same question, some extra steps. That's all. Any doubts on this? You want me to explain this once again? Okay, man.